Question 5. So a particle moves and the velocity of the particle is given by the function e to the power of sine t plus 4 sine t. And t is between 0 and 6. So at A we need to find when the particle is at rest. Now the particle is at rest when its velocity is 0. So what we need to do, we need to plot this function of t using the calculator and see when it intersects the x-axis. So then the y-axis, which is the velocity, will be 0. So I here used another software to do the graph, and we need to look at the graph just between 0 and 6. So between 0 and 6 there is only one interception point, and the value is 3.347. Let's say 3.35. So this is the answer for A. Now B, we need to find the acceleration of the particle when it changes directions. Okay, so we are given with the velocity. How we get from the velocity to acceleration? We just differentiate the velocity. A of t will be the acceleration. So we can do that using the calculator, or we can just do it manually, like I will do it here. So we have e to the power of sine t plus 4 sine t, and we want to differentiate it, so it's e to the power of sine t time cosine of t. So when we have an exponential function, its derivative is simply the exponential function again times the derivative of what that sits in the exponent, and here we have 4 cosine of t. So this is the term for the acceleration, but we need to find the acceleration only at a specific time point, which is exactly when the particle changes direction. So where the particle changes direction, again this is the velocity. So, and we are between 0 and 6. So when the velocity changes the sign, then it means that the particle changed its direction of motion. If it was positive here, it moved in one direction, and starting from this point that we already calculated, the velocity will be negative, which means that it moves in the other direction. So what we need to do now is calculate A at t equals 3.35. This is the point, this is the time where the velocity sign changes. So I'm just going to use the calculator to put in this t value to this term, and I get an answer of negative 4.71. And this is the answer to B. Okay, now C, we need to find the total distance traveled by the particle. So the total distance, x of t, we have a formula for that in the booklet, is the integral from the beginning of the motion t equals 0 to the end of the motion t equals 6, and we integrate the velocity, but we take it in absolute value. And here we have to notice that we have to use the absolute value in order to calculate the total distance. If we don't use the absolute value, we just get the displacement of the particle. So the velocity is known. Yeah, the term is known. So one way to do it is simply to plug in the calculator the term, the integral that we need to calculate. Just be careful to put it with absolute value in order to get the right answer. I will show it here with a bit more information. So I will do this integral actually with an absolute value. So again, we have here the function of the velocity, and until the point of 3.347, the integral on over this function will give us actually the area that is between the function and the x-axis, and this area here is positive. Now above 3.347, the area that we get is actually negative, but we want it in absolute value. So what we're going to do, we're going to divide the integral into two parts. We're going to take it from t equals 0 to t equals 3.35, and then we just do it over the function vt dt, and we don't take the absolute value here because we already know that it produces a positive value, so the area is above the x-axis and it is positive. And now for the second integral, we know that the area is under the x-axis, and this will give us a negative value for the integral, but we want it as positive, so we add another minus before v in order to turn it from negative into positive. So in order to really do the integral, I use the calculator, and I get here for the first one 13.31, and for the second one 6.44, and all together we get that the total distance is 20.75, and this is the answer for C.